at question number 2, first part. So in the first part, we have been given a constraint maximizing problem to maximize x square plus y square subject to x plus y less than equals to 1. So you can think of this as a budget constraint problem, right? You can think of this as a budget constraint problem wherein your utility function is described as x square plus y square. So your ICs are going to look like this. Let me use these shapes. Okay, so that is what your ICs will look like, and your indifference curve, your budget line is so your budget line is x plus y is equals to 1. Okay, so your budget line, effectively it will look like this. Not this particularly, but let's say something like this. Okay, so given this budget line, what is the best you can do? The best you can do is either on this corner or this corner. So those are the two optimas. So the answer here is going to be either x is equals to 0 or y equals to 1. So 1 comma 0 or 0 comma 1. So these two are the maximas. So remember this indifference curve, this IC is concave. Okay, so when you have concave ICs, what you have is corner solution. Don't try to solve it using Lagrange. What Lagrange will do is Lagrange will give you this particular tangency solution. Okay, so whatever there would be a tangency solution here somewhere. So this is what Lagrange gives you. Lagrange gives you the point of tangency of IC with the budget line. That's not what we are looking at. So don't try doing this using the Lagrangian method. Okay. Now let's look at question number 2. Question number 2 is a very desperate attempt by ISI to include some sort of a puzzle into the paper, and it's basically a puzzle you can find solution of anywhere, maybe even some family WhatsApp group. So in this there's a king who has invited 1,000 guests, and they each bring a wine, and one of 1,000 wines is poisoned. He has 10 prisoners who he can spare their life with. It's a pretty cruel question. So he doesn't care if these 10 people live or die. So what he wants is some sort of mechanism in which he can figure out which wine is poisoned using these 10 prisoners. So the key here is that 2 to the power 10 is equals to 1024, which is less than 1000. So what you can do is you can give a binary code of 10 digits to each and every wine. So suppose wine 1 is 0000000. How many zeros? There are a lot of many zeros. 0000001. So this is basically, let's say, wine 1. Okay. Similarly, you can give wine to this code. Everything else same. Wine 2 could be 000000010. So this could be wine 2. So you could have different wines given different binary codes it is possible to do for 1,000 wines, because for a 10-digit case you can have 1024 different wine situations. Okay. So then what you do is you have a mixture of these wines. Okay, so what you can do is basically you have 10 prisoners. Okay, so the first position corresponds to prisoner 1, prisoner 2. Okay, so let me call them ABCD for ease. A, B, C, D, E, F, G, H, I, J. Okay, so this is what you do. You make a matrix of these 10 prisoners. So wine 1 corresponds to the quotient for wine 1 is 0 0. Okay, let me use another color. So wine 1 is 0 0 0 0 0 0 0 0 0 1. Okay, wine 2 is all zeros 1 0, and so on. There will be different thousand different combinations. Then what do you give to first prisoner? Okay, so jth prisoner will get a combination of all those wines for which he's getting a positive score. So jth prisoner will get this wine. Okay, so let's say there's some nth wine for which the binary code looks like 0 1 1 0 0 1 1 0 0 1. Okay, so this is the binary code for the nth wine. So basically you are going to give this wine to prisoner B, prisoner C, prisoner F, and prisoner G, and prisoner J. So these are the 5 prisoners you give this wine to. Now if the next day you find out that these particular 5 prisoners have died, sorry, not these 2, if you have found out that these 5 particular prisoners die, you know that this was the wine which has killed them. So suppose in the second day you find out that between A, B, C, D, E, F, G, H, I, and J, the prisoners who have died are, let's say, C, F, and J. So the binary code of the wine which is poisonous corresponds to 001 001 0001. Okay, so the binary code of this wine looks like this. Now I don't know if this king had a computer to do this or not, but compiling the binary codes and everything is pretty damn difficult. It's not an original question. That's what I don't like about this. I mean, had it been an original question, I would have respected ISI for that. The problem is they've copied it from the internet. So it's sad. But it's an interesting problem, provided you can solve it in an exam.